Imagine looking up at the night sky. It is quiet. It is dark. The stars are burning steadily just as they have for billions of years. Then, in the blink of an eye, a flash appears. It is a single point of light, but for a few seconds it outshines the entire galaxy. It outshines 100 billion stars combined. It is the brightest, most violent event since the Big Bang. And then, it is gone. The universe returns to silence. But in those few seconds, a beam of death has traveled across the cosmos, capable of sterilizing any planet in its path. We didn't find these monsters because we were looking for astronomy. We found them because we were looking for war. The year was 1967, the height of the Cold War. The United States signed a treaty with the Soviet Union banning nuclear tests in space. To enforce this, the US launched the Vela satellites. Their job was to watch for the sudden flash of gamma radiation caused by a Soviet nuke. On July 2nd, the satellites triggered. They detected a massive explosion, but there was a problem. The flash didn't come from Russia. It didn't come from Earth at all. It came from deep space. The military was confused. The astronomers were terrified. Something out there was detonating with the force of 1 trillion nuclear arsenals. To understand the danger, we have to talk about scale. Our sun is a beast. Every second it burns 600 million tons of hydrogen. It has been doing this for nearly 5 billion years, and it will continue for 5 billion more. But a gamma-ray burst, or GRB, releases more energy in 10 seconds than our sun will emit in its entire lifetime. Take 10 billion years of solar fire, compress it into a heartbeat. That is the power of a GRB. It is a violence that defies the human capacity to comprehend. How is this possible? How can one star be so bright? The secret is focus. When a normal star explodes as a supernova, it sends energy out in all directions like a light bulb. The energy is wasted on empty space. But a gamma-ray burst is different. It is like a laser. When the star collapses, the energy is funneled by magnetic fields into two tight, narrow beams shooting out of the poles. This is called a jet. Because the energy is focused, it travels further and hits harder than anything else in nature. This mechanism changes the rules of the game. The universe is full of these explosions. They happen every day. But usually the jets are pointing away from us. We see nothing, we are safe. But if the jet is pointing at us, then we are staring down the barrel of a galactic sniper rifle. The distance doesn't matter. Even from thousands of light years away, the beam is so focused that it can strip our atmosphere and burn our world. The universe has a gun, and it is spinning in the dark. Where does this ammunition come from? There are two ways to build a galactic weapon. The first is the hypernova. This creates the long burst lasting more than 2 seconds. It happens when a supermassive star, 30 times heavier than the Sun, reaches the end of its life. The core collapses into a black hole. But instead of a quiet death, the star is spinning so fast that the black hole acts like a dynamo. It eats the star from the inside out, blasting the excess energy out of the poles. It is a star, screaming as it is devoured by its own heart. The second method is faster and violent. The short burst. This happens when two neutron stars collide. When they smash together to create a kilonova, the impact is so catastrophic that it briefly creates a jet of pure gamma radiation. It lasts less than 2 seconds, but in that 1 second it releases enough energy to vaporize the atmosphere of any planet unlucky enough to be nearby. The scariest thing about a gamma-ray burst isn't the power, it is the speed. On Earth, if you see lightning, you have a few seconds to cover your ears before the thunder hits. But in space, the lightning is the thunder. Gamma rays travel at the speed of light. This means the image of the explosion arrives at the exact same moment as the lethal radiation. We cannot see it coming. Our telescopes cannot warn us. If a star exploded 1,000 light years away, we would live in ignorance for 1,000 years, and then, instantly, we would be dead. Has this ever happened to us? The forensic evidence suggests, yes, 450 million years ago, the Ordovician extinction. It was the second worst mass extinction in history. 85% of all marine species vanished. Paleontologists found a strange pattern. The animals that lived near the surface of the ocean died. The animals that lived deep underwater survived. This matches the profile of a UV radiation bomb. Some scientists believe a gamma-ray burst hit the Earth, stripped the ozone layer, and boiled the surface dwellers alive. The deep sea was the only bunker left. What if it happened today? It would start with a flash. If you were on the daylight side of Earth, the sky would suddenly turn a blinding electric blue. If you were on the night side, the moon would glow brighter than the sun. In orbit, every satellite would fry instantly. GPS, internet, television gone in a millisecond. The astronauts on the space station would receive a lethal dose of radiation before they could even float to the escape pod. Down here, we would look up confused. We would have about 10 seconds to wonder what that pretty light was, and then the atmosphere would begin to unravel. The flash itself won't kill everyone. The real killer is chemistry. Our atmosphere is made of nitrogen and oxygen. They are usually stable friends, but when a beam of gamma radiation strikes the upper atmosphere, it smashes these atoms apart. They recombine into something toxic. Nitrogen oxides. This is essentially smog, a brown poisonous haze that wraps around the entire planet. But the tragedy is what this smog does. It eats ozone. Within minutes of the burst, the Earth's ozone layer, our only shield against the sun, would be shredded. We would be naked against the stars. With the shield gone, the sun becomes our enemy. Lethal ultraviolet radiation, UVB and UVC, would pour down onto the surface. This isn't just a sunburn. This is radiation sickness. If you walked outside during the day, your skin would burn in minutes. Your DNA would be shattered. Blindness would become common in animals and humans. The surface of the Earth would become a sterilization zone. The only safe places would be underground or under the dark cover of night. But the land is not the biggest problem. The ocean is. Life on Earth depends on the ocean, and the ocean depends on phytoplankton. These microscopic plants live near the surface to catch sunlight. But without the ozone layer, the UV radiation kills them. The base of the food chain would be wiped out. First, the plankton die. Then the krill starve. Then the fish. Then the whales. And finally, us. Humanity would not die from the blast. We would die because the ocean stopped feeding us. And then the temperature drops. That brown smog, the nitrogen dioxide, doesn't just kill ozone. It blocks sunlight. It acts like a reverse greenhouse gas. The Earth would darken. A cosmic winter would set in. Crops would fail. Glaciers would advance. It is the ultimate irony. The event starts with a blinding flash of heat and ends with a long, slow freeze. This terror teaches us something about real estate. Location matters. The center of the galaxy is crowded. Stars are packed together. Supernovae and gamma-ray bursts happen there all the time. Life in the galactic core likely never gets a chance to evolve before it is sterilized. It is a dead zone. We are lucky. We live in the suburbs, the galactic habitable zone. We are far enough away from the crowded center to be safe, but close enough to have enough heavy metals to build planets. We are hiding in the quietest corner of the city. So is there a gun pointed at us right now? Possibly. Meat? It is a binary star system located 8,000 light-years away in the constellation Sagittarius. It looks like a beautiful golden spiral. This pattern is created by two massive stars orbiting each other and spewing gas. But here is the terrifying part. We see the spiral as a perfect circle. That means we are looking at the system from above, looking directly down the pole of the star. Remember, gamma-ray bursts fire from the poles. We are looking right down the barrel. WR-104 is a ticking time bomb. It will explode as a supernova eventually, if it generates a burst, and if the aim is true. The beam is heading straight for us. This fear makes us look at every dying star with suspicion. Take Betelgeuse, the famous red giant in Orion. It is due to explode any day now, astronomically speaking. But we don't need to worry. First, Betelgeuse is likely losing rotation speed, so it probably can't make a focused jet. Second, its axis is tilted away from Earth. When Betelgeuse dies, it will be a spectacular light show, visible even during the day. But the sniper shot will miss. We will have front row seats to the fireworks, without the danger of the fire. But even if we are safe now, the existence of these weapons might answer a bigger question: where are the aliens? Some scientists believe gamma-ray bursts are the ultimate great filter. In the early universe, these explosions happened constantly. They sterilized galaxies every few 100 million years. Maybe life is common, but advanced life is rare because the universe keeps hitting the reset button. Maybe we are only here because the universe has finally calmed down enough to let us survive. We are the survivors of a cosmic ceasefire. So, if WR-104 fired at us tomorrow, would it be the end of the world? It would be the end of us. The end of civilization, but it would not be the end of life. Biology is stubborn. Humans deep underground would survive. Bacteria in the rock would survive. The creatures around hydrothermal vents wouldn't even notice the flash. Evolution would take a step back. It might take millions of years to recover, but the Earth would bloom again. You can burn the surface, but you cannot easily extinguish the spark. We live our lives assuming the sky is safe. But the story of the gamma-ray burst teaches us that we live under a sword of Damocles. The universe is not a peaceful garden. It is a violent, active machine. This shouldn't make us afraid. It should make us grateful. Look at that thin blue line of atmosphere. It is the only shield we have against the dark. It is the only reason we are breathing. Cherish it, because in the cosmos, safety is the exception, not the rule.